Thank you everyone for joining us today at the Energyflex panel. Apologize for these technical difficulties. We were just trying to figure them out up until the last minute. But I'm Jennifer Dane. I'm a research application manager at the Turing. And before I turn it over to the panel, I'd just like to share a few resources that we'll be using during the panel. So as you can see, there's a pinned Google Doc. I've also just dropped it into the chat. You can see there on the side in Hopin. So the Google Doc will contain some information about the panel, some useful links, also how to get in touch with different people after the workshop, as well as at the bottom of the document, we have a place for you, the audience, to add your names, questions, any notes you have. I believe they're also holding time at the very end for any comments and questions. But during the panel, feel free to just drop those in the Google Doc. So now I will turn it over to Andre. Welcome, everyone.
Thank you very much. And yeah, good afternoon and a very warm welcome to our workshop on the Energyflex project this afternoon. My name is Andre Neto-Bradley. I am a research associate at the University of Cambridge and part of the Energyflex team. And this afternoon, we'll be exploring the potential for microsimulation models such as Energyflex to address inequalities and challenges in improving energy efficiency of housing. Now, those of you who watched the last session of the day yesterday will have heard Sir Patrick Vallance talking about the use of data science for public good. And he made the point that to get people to embrace data science in shaping decision-making, the end users or beneficiaries have to be given a glimpse of what this can do for them. And he was obviously giving the example of COVID and COVID modeling. But hopefully today's workshop will give you a bit of a glimpse of what simulation tools like ours could do for understanding trends in local energy efficiency, as well as give us some food for thought about how to develop this going forwards. Now, our workshop today will start with a short demonstration and introduction to Energyflex and our microsimulation model that we've been developing before we move on to a panel discussion on the challenges in decarbonizing housing stock and how data science and simulation tools could help locally target solutions. And as Jennifer mentioned, you will all have the chance to join in the Q&A session. So please do type your questions in as they come up, and we will address them at the end. But yeah, and if you have any other technical issues as well, feel free to put them in the chat, and Jennifer can pick them up as we go along. Now, this project is a collaboration between researchers at the University of Cambridge and the University of Leeds, as well as Daphne, the National Data Analytics Facility. And the team on this project brings together expertise in spatial and agent-based modeling, as well as expertise on building simulation and the socioeconomics of energy use. And this melding of expertise is pretty key to our approach. Now, it is also useful to have a little bit of background on why we've been developing this. And about 10% of carbon emissions in the UK come from residential heating alone. But decarbonizing residential energy demand requires identifying opportunities and improvements and opportunities for change at a household scale. And the truth is that data at this scale is often not available or offers only limited information at that scale. And so with this project, we are combining a synthetic population with an energy model to simulate the data that would otherwise not be available. And we're not just interested in sort of finding flexibility in demand, but also, crucially, supporting flexible and locally tailored approaches to decarbonization. So what does this look like in practice? Now, don't worry, I'm not going to give you a lecture in data science and modeling, but it is useful to have a bit of a big picture overview of how our model works. And we start by taking publicly available data, and we use this to generate a synthetic population that's representative of the population within a local area, but they're all not real, which is pretty crucial. And we can use energy modeling approaches to estimate not only the energy efficiency of the homes that these households are living in, but also some of the building performance characteristics. So for example, the thermal fabric or the efficiency of the heating system of those homes. And using that synthetic population with those energy performance characteristics, we're able to simulate and test out policies and solutions on a household by household basis, not only taking into account technical criteria, but also considering the socioeconomic context, which is often left out of such analyses. Now, at this point, some of you in the audience may be wondering, what about the EPCs, or the energy performance certificates? Now, these are a form of public record that details the energy efficiency rating of a property, and they are really useful. In fact, they are an input to our model, but they are not a replacement for a micro simulation of the population in the local area, because first and foremost, they are a kind of a biased record. They only include homes sold or rented since 2008. They often have small mistakes or sort of inconsistencies in some of the variables that they include. So the headline values are one thing, but some of the more minor values and sort of ratings that they include are sort of approximated. Crucially, there's no information on socioeconomic context, and the data is not anonymous. And again, if you were at any of the sessions yesterday, there was a good discussion about privacy and data used for decision making. And obviously, the EPCs actually have a physical address. You can pull up the record and go to the address of the house. So using this data does raise some research ethics questions for us. But enough about what Energyflex is and isn't. But what can we use Energyflex for is a good question. And the first thing we've done with this actually has been to use the model to explore spatial trends in energy efficiency of homes. For example, here we've modeled the energy intensity of homes built since 2000 for all local authorities in England. So the bluer, the better, the redder or more yellow colors are worse. And we can see a distinct spatial pattern from north to south, and especially sort of southeast and the rest of the country. And we've written a piece in the conversation about this actually, and if you scan the QR code on the bottom of that slide there, you can go and read more about this. But the one key takeaway was that this trend in energy efficiency of homes correlates rather strongly with house prices and disposable incomes actually. And this suggests a compounding effect of inequality here, where actually those who are likely to be on lower incomes to begin with are also likely to live in areas where the housing that's available for them to rent or buy is less efficient. And so there's sort of an increased risk of fuel poverty, especially at the moment with the skyrocketing price of energy. But we can actually zoom in even further with our model, and we can look at trends across different ages and different types of housing within a local authority. So for example, here we're looking at the northeast cities like Leeds and York in this region. And one of the things that we see here actually from an analysis of our model is that terraced housing and flats in larger urban areas tends to be a little bit more efficient than in other places, suggesting a slightly greater uptake of retrofit solutions in those areas. Home improvements, maybe greater percentage of double glazed windows put in and improved boilers and whatnot. So this is all really useful in and of itself. These trends are useful for decision making and sort of planning things. But the true value of Energyflex is its ability to simulate how a decarbonisation retrofit for a building might benefit the homes in the local area, and how to best roll that out. And it's worth saying here that we're still at really early stages in developing this, and so this is work in progress. But we wanted to give you a demo, if you will, of what we'd be able to do. And for this example, let's take the case of Haringey in London. Now, if we look at the housing types in Haringey, we see that actually most of it is flats And not just that, but a lot of the vast majority are flats built before the year 2000. So let's take a closer look at these. Let's say we're interested in inefficient heating systems, right? We want to target those for improvement. So Energyflex is able to model the likely energy performance characteristics of the building's thermal fabric, as I mentioned, but also things such as the likely efficiency of the heating system. And from this, actually, for Haringey, we find that over 40% of flats built between 1930 and 1970 and 1970 and 2000 are likely to have older inefficient boilers. And for the case of this example, I sort of said that's an E-rated boiler or worse on the old ZBUC boiler rating scheme. And this in and of itself is very useful for sort of calculating the potential carbon emissions reductions you could get from installing a more efficient heating system. But we can take this a step further, actually, and we can also look at the socioeconomic context here. So, for example, we can see that from our model, households in 1970s to 2000s flats are likely to be on a lower socioeconomic band, and that has important implications in multiple regards. On the one hand, they may be less able to afford the cost of a retrofit if they have to pay for it themselves. You know, if they're putting in a new boiler, that might be a larger chunk of their monthly income. But it also suggests that they're at greater risk of fuel poverty in the first place, and so addressing the inefficiency of their home is quite important. We can also look at other things, such as who owns the house. So in this example of Haringey, there's actually quite a bit of variation. So the flats built between 1930 and 1970s are mostly private rentals. So those are private landlords who own those, and the people who are living in the property don't actually own it. Whereas the 1970s to 2000s age band of flats, that's actually, there's a lot of social rentals there. So imagine that we want to consider putting in or replacing all these boilers with air source heat pumps. Energyflex would let us sort of simulate that and sort of point out, first of all, that the greatest prevalence of inefficient boilers is in the 1930s to 2000 flats. So they'd be sort of the low-hanging fruit to target first. The model would also point out that flats built between 1970s and 2000s, that the households living in them are more likely to need financial support and may be more vulnerable to fuel poverty. So it'd sort of be an added benefit of the retrofit there. And crucially as well, our model would point out that to improve the efficiency of boilers in 1930s to 1970s flats, you'd have to actually find some way of incentivizing the private landlords to replace those boilers. And so this is not a be-all and end-all, but more a glimpse of the kinds of questions and kinds of issues that we can look at with our model. And at the moment, you know, some of the questions we're thinking about are, for example, what kind of policy questions and what kind of challenges could we use this to address, and how could we use it to locally tailor decarbonization policies? So we kind of walked through an example of pre-2000 flats in Haringey, but what would that process look like elsewhere around the country? And to help us think about some of these questions and more, we now turn to our panel of speakers today, who bring together a diverse range of experiences on energy efficiency and decarbonization of the UK's housing stock. Now, you've already seen Dr. Ruchi Chowdhury on our team slide at the beginning of the talk. Ruchi is a professor of architectural engineering at the University of Cambridge and leads the research group on digital twins of the built environment, part of the AI for Science and Government program at the Alan Turing Institute. Her work focuses on simulation methods for predicting and modeling energy demand of the built environment. And at Cambridge, She leads the multidisciplinary Energy Efficient Cities Initiative, whose research you may have seen featured in a number of the lightning talks between sessions this week. We also have with us David Shewan, who is Technical Director at Parity Projects, and thankfully has joined us despite some technical issues. And he's been involved with Energyflex a little bit as well, actually, including providing some data for calibrating our model. David works on development of housing advice and analysis work at Parity Projects, and while he did originally train as a geologist, he gave up a career in petroleum exploration to take action on climate change instead, and has been working with Parity Projects, I think, since 2008, and takes a particular interest in data analysis and how that can be used to make the business case for energy efficient retrofit work. And last but certainly not least, we have Dr. Gemma Burgess, who is Director of the Cambridge Centre for Housing and Planning Research. Her research interests include opportunities that digital innovations present for housing, the relationship between housing and ageing, health inequalities, and equality issues more broadly. And Gemma is involved with the leadership of the Construction Innovation Hub, a partnership between the Centre for Digital Built Britain and Building Research Establishment and the Manufacturing Technology Centre. So Ruchi, David, Gemma, thank you so much for joining us today. Now, the first question actually that I'd like to pose to all of you, I've been talking about modeling energy demand for simulated houses here, but I'd actually like to start by focusing on the real world housing stock for a moment. And when we think about energy efficient homes, we might think it's a straightforward case of putting in more insulation or something like that to all the houses around the country. But actually, what sorts of challenges are faced at an individual or local level when trying to deliver more energy efficient homes? And Gemma, I'd like to start off by getting your perspective on the sorts of challenges there are to decarbonizing residential energy demand, especially looking at it from sort of a local planners or local government scale. Yeah.
So thanks, Andre. I think it's a fascinating model, very interesting. You've got a bit of an echo there. I think one of the big issues here is about individual homeowners. You know, when an individual homeowner is trying to think about their own energy efficiency, the big question is affordability, and you've touched on socioeconomic circumstances, but what are the financial viability of different interventions? How do people trust those interventions and the technology that is being suggested that they use? You mentioned air source heat pumps. How do people know that that's the right thing for their individual home, that it's worth the investment, that in 5 years' time that technology won't be obsolete or surpassed by something else? Even once they've got that information, how do they find somebody to fit something like an air source heat pump, to maintain it? How can they trust the trades, the supply chain that's going to deliver those energy interventions? What are the sorts of trade-offs that they're going to need to make with other types of home expenditure? And a lot of the argument for making energy interventions in your home is about financial savings, but how do people trust that? How do they know it's going to be over a timescale that makes sense to them? And you've touched on issues around socioeconomics and fuel poverty. As you identified, a lot of those households are the ones who are in the greatest need, but they also have the lowest income and opportunities. And if we think that about 10 million people in England live in a non-decent home, so that presents a serious threat to health and safety, the challenges in those households around damp, cold homes that are a danger to health are very significant. But the key issue is, how do you find the information to know what to do for the best? And then the challenge around who should pay for it and how. And particularly for local authorities who are trying to shape policy that might support households, finding the right information to do that is really difficult. Oh, you're on mute.
It wouldn't be a virtual workshop if I didn't accidentally speak up at least once. But actually, I was saying that brings us on very nicely actually to David. This is obviously something that is right up Parity Project Street, sort of thinking about how sort of making that case for the financial viability of improvements and sort of giving people the information to make those decisions. I was wondering, David, in your experience, sort of what are the challenges in sort of communicating that to homeowners or landlords or local councils, and sort of, yeah, what challenges do you find there?
So, I mean, I've been into lots of people's houses and chatted to them about energy efficiency, and I'm always amazed that they'll spend so long talking to me about it. People are very engaged, and I mean, if I'm going and doing a survey for somebody, it would be it wouldn't be unusual that I'd be chatting to them for an hour about various aspects of their energy efficiency. This said, that's just not enough. I think when you look at other things in the space, I think people are vaguely aware that one day they're going to have to get an electric car. I think they're just beginning to get to the idea of one day they need a heat pump. But we just don't have the demand. When people are talking about improvements to their home, I think when all the spending, 10 or 15 or whatever it is, grand on your home is kind of likely to be, if it falls into your consciousness, it's likely to fall below the loft extension or, replacing the doors downstairs or whatever it is that you're planning. So, I mean, I know this bleeds into perhaps a future question, but it would be nice if there was a clear vision. That said, I mean, we do a bit of micro simulation ourselves, and I think what we've kind of seen as our role is perhaps not to lead the policy, but to equip people with the tools, to find out the answers to the questions that they want the answers to. I think in your presentation, you talked about flats in Haringey and how they might be suitable for heat pumps and all those sorts of things, and people just don't fit into those sorts of categories neatly. There's a question from William Beckwith rather, which is what makes AI a good solution to this kind of problem. I mean, to me, we've sort of got a number of givens for all these properties, and we can see that all these flats in Haringey, have less efficient boilers, and so you might do that. I think the key thing is trying to find out what things push people's buttons. How can you get at the stuff where you don't have these sort of givens? So there are loads of interesting things that we'd like to be able to get at, like how likely is the client? I'm saying client. How likely is the householder to do something about this? Are they likely to have problems that we can't see, like damp or mold issues is something that's very much a big thing for housing associations, for example. So I mean, that's the places where we're trying to we've got a very analytical approach, exactly as William says, to these sorts of things, just getting kind of deeper to the stuff where we don't have a lot of wide data, where we just have deep data, a small number of homes, and extrapolating it to try and target these sorts of interventions is the best. I think the other challenge is the supply chain, because we've had a lack of ambition from the government, a lack of direction from the government. The installers that have been successful have been the ones that have been cautious and that haven't kind of backed the big horse when it's turned up from government and then subsequently disappeared without trace. A lot of companies have gone bust that way. So what we've got is a very cautious, small business type approach to installers. And I mean, if anyone's tried to find an installer recently for a home project, you can sympathise, and it's even particularly more the case in terms of the type of measures we're talking about. Final challenge, I think, is government, but we'll move on to that.
No, that's really interesting, and actually, I think there's a point there I wanted to ask Ruchi about, which is sort of this when we're working in simulation and modeling, we often make a lot of assumptions about the people in our models and how people behave in our models, and there's it's very tempting to assume that people are sort of all well behaved and do the same things and behave in the ways we expect. But actually, that in itself is sort of an added challenge, isn't it, to improving energy efficiency of homes. We can model and simulate one thing, but then in the real world, there's also a bit of a mismatch there. I don't know. Yeah, I don't know, Ruchi, if you have anything in particular on that.
Yes. So one part of it is that, yes, there's, in general, there is a mistrust towards the kind of techno-economic modeling that we have been doing. But I think that we've come a long way over the last decade on that. There is definitely much more information from the real world. And, David's work also demonstrates that, even councils are able to tap into the variety of data that we have at the moment. The challenge, I think, still remains with respect to what Gemma also alluded to, is that we have to understand what will be effective in terms of the kind of information that will be attractive to people. And accordingly, we have to push data and translate data into information that makes sense. part of that is that, what is it that will make people trust the information that they are getting? What is it that will incentivize them? And we need mechanisms by which we can translate data into information such that it's easier to do the retrofits that are needed than not to.
Yeah.
We have these kind of products that can incentivize people missing at the moment, and I think that's one of the big barriers.
No, and just following on from that, kind of, and leading on to a sort of second overarching question here, which is a little bit this issue of heterogeneity and local variation in challenges, right? Because, I guess the question to consider is sort of where might the sort of one size fits all approach to policies on this fall short, right? You think of measures like a £5,000 subsidy for installing an air source heat pump, but that's not maybe going to work for everybody in the same way. And I guess, Ruchi, I was wondering how much of that is, how much of that unsuitability of one size fits all comes down to the actual building physics versus some of the socioeconomic stuff?
It's both. It's both. So I can walk on a street and I can identify with respect to physicality where this kind of subsidy of £5,000 would work and where it won't. So it does matter. The basic physics of the house, it's very, very important. But at the same time, it also boils down to affordability. So, it's both. It's both. And it's not just affordability, it's also viability. So as you pointed out, a lot of the homes are privately rented in many areas, whereas, a large swaths of UK is private owned. It's a nation of homeowners or aspiring homeowners. And then we also have a huge percentage of the social housing stock. So who pays is important with respect to incentivization. So the financial part is one thing. The second part is the disruption. That what kind of disruption and what period of disruption it will entail in installing a particular retrofit. So in some homes, it may be easier than in other homes. Then another factor that we don't take into account is that often it's one structure, but several tenants or several owners within one. So what is a building also becomes a question there. And if you have to retrofit, if the premise for a heat pump to be able to work, which we all know, is that you also have to have a efficient house. Otherwise, you're just going to lose the heat and you're actually going to end up paying more. So if you're going to do a retrofit, then you have to have buy-in from multiple people rather than one person, often. So that becomes another issue. So I think there's several layers there to work through.
Yeah, and actually, and at this point, I actually want to circle back to you, David, because I think you're sort of mentioning government being part of the problem, and I guess, yeah, from your experience, sort of working with individual clients and individual sort of homeowners and landlords and whatnot. Yeah, I guess how much do you see this mismatch of sort of a one size fits all approach with the actual challenges that an individual building has or an individual household has?
I'm not sure we have a one size fits all approach so much as maybe the government just has a single hammer, if you see what I mean. There's and it's not a very good one. I keep coming back to something that I remember seeing, which is the market transformation program. Used to be a thing about 10 years ago, and they had a lovely model which had a sort of a Napoleon's hat curve describing the market and how they want it to be, and they kind of placed different types of government policies on it in different places. And so you can see at the early adopter type stage, you might have grants to encourage innovative products to join them, and at the end you might be putting kind of things that require homes to get to a certain minimum standard. And so we're beginning to see some of those sorts of things, but really at the moment all we've got in policy is grants and MEES, basically minimum energy efficiency standards, and which are pretty punk, to be honest, for very low performing private rented homes. I mean, we've seen horrible problems with grants. I mean, just taking these. I mean, it makes sense to me that you should continue to have grants for the people who can't afford to put measures in homes. But when you look at these grants, Eco 3, 93% of the money I think in Eco 3 spent on boilers was spent on replacing boilers from Eco 1 and Eco 2, which can only have been 8 years old at best and 3 years old in some cases. And it was right there in the consultation. I mean, I don't want to point in this one in particular, apart from that it's illustrative of a problem with grants, which is that grants tend to be subject to loopholes and they tend to be exploited. And so the grant gets more and more complicated and people find more and more ways of getting around it. The other problem about grants is that looking at this latest round of £5,000 grants for heat pumps, the question is, what can we expect to happen when these grants are brought in? And I think the answer is we can expect the price of heat pumps to go up by about £5,000, and we can expect the market to be limited to the number of grants that there are. Because who's going to want a heat pump when the grants have run out? What they'll happen is they'll say, oh, we'll go on the waiting list when the new grant comes along. I think the final thing is, if we're trying to put a heat pump into every home in the country, the government just can't afford to give enough grants. Yeah. And so what happens is that the government is artificially inflating the price of the market. They're limiting the market to a small number of homes. And I mean, it's just all ridiculous, really. So so you can see I'm not a particular fan of grants, but I've seen this cycle happen 3 or 4 times in my career now. It's just hopeless. So I think this comes back to my thought of data. So I mean, we run a micro simulation model. Mm-hmm. The data isn't perfect. We reckon it's about 85% correct based on ground truth. I mean, you've got to pick a level at which it's correct. So to me, all models will be incorrect when you go deep enough down into them. But when we've described a home according to 10 key characteristics that a typical householder could assess, we came up with that 85% number. But that's enough to provide good quality advice, and it's good enough to provide targeting. I think the next level at which it'd be nice to see microsimulation is just a completely different type of modelling, which is if you can model actual energy performance against how you might expect it to happen. So, for example, so basically saying, once we've installed a certain measure in your home, we expect to see this saving, and we can guarantee it with insurance, for example, insurance-backed guarantee on your savings. Because after all, what we're trying to get people to do here is save energy, and that's something that will save money. If you can link that to a product that will that will finance the measures, then all of a sudden you've got people installing measures for free that will save them money and make them more warm and comfortable in their homes. And the government doesn't have to shell out money on grants, which are never going to work unless they're effectively investable, which the government never wants to happen. So just quickly coming back to Rishi's point about housing associations and landlords, I tend to think that housing associations aren't the problem. Housing associations are just brilliant organisations trying to do the best they can for their tenants, and they all tend to have fairly realistic net zero strategies which get their homes very affordable. I despair of landlords and what's going to happen, but the big lump of the market is the able to pay. So looking for ways of motivating these people to actually do stuff is very interesting, and I think that's where this level of microsimulation can come in terms of targeting those people and providing them with the information they need to make decisions. Trying to get the Tesla factor into housing.
Yeah. Gemma, I won't put you on the spot for a yay or nay opinion on grants or anything like that, but I was wondering what your thoughts were on this issue, sort of the sort of current approach to policies and sort of I guess the support for measures through grants.
I mean, I think that one of the big issues is that the policy is very weak. So we have some national policy around net zero, energy efficiency, but it's certainly not very strong policy. We have some regulatory drive to push up EPC ratings in the private rented sector, but most homes are in home ownership. And there we've got very little policy to drive change around energy efficiency. I think we're very reluctant, other than maybe putting in grants that we see as small carrots, to put anything in that's more of a stick in the home ownership sector. And I think that's where the biggest challenge is. I also think that local and national policy is more focused on what we should do in new developments. So how do we deliver net zero? What should be the planning around that, rather than retrofit? And yet retrofit obviously the biggest challenge, because that's the majority of the stock that we've already got. So I think there's a question in there as well around what's the role of the local in policy? What's the role of local authorities in setting a policy agenda when most housing is in home ownership? So I don't think it's very clear what the role of a local authority would be there is their role to provide information? Is their role to provide one-stop shops so that people know? Is their role to try and grow that supply chain? We know that there's very little in the way of a sort of green supply chain for providing these energy interventions. There's a huge need for upskilling, for training, for the creation of new jobs. Is that the role for local policy? So we think that there's a bit of a vacuum at the local level where it's not completely clear what local authorities could or should be doing. And I think when we look at the housing association stuff, and David mentioned this, and he's quite right, that housing associations, and we work with housing associations, are very focused on what should we do and what can we do for our tenants. But they themselves are having the same scratching of heads that individual homeowners are doing. What's the right way to invest? What should we be doing? And what they really want is they want better information and data on, you know, when you've owned a large housing stock portfolio and you want to make energy interventions, they want to know what's going to be cheap, what's going to be quick, and also what's going to be most cost effective for their residents and may therefore be worth spending more money on. And I think a lot of housing associations are struggling with that decision making and need some help and data to help them make those decisions.
No, I think that's, yeah, I think that's a good point. I think it's interesting that you've all sort of come to a similar point from different vantage points. And I guess the sort of final question here for the panel was, you've kind of addressed it a little bit already, but this idea of sort of, I guess, what role microsimulation approaches and sort of spatial modeling tools, a bit like Energyflex, what kind of role they could have in addressing this. And obviously, you know, the need for sort of better information and sort of people making sort of people feel like it's a better financial decision, or that they're willing to put their money behind it, is one part of it. But actually, I just wanted to go back to David on this, a point you were saying sort of about, yeah, I guess where there is space for more microsimulation tools in terms of, you know, I was quite interested actually by this point, this insurance-backed idea you had of sort of that you have a modeled energy performance and you sort of check it against what actually is there. I was wondering, is that something that, you know, a kind of microsimulation sandbox where you could sort of test out and model the likely performances? Would that give you the certainty to sort of have an insurance scheme behind that, do you think?
I think what would give you the certainty is if you could show that it works on a large number of homes.
Right.
The problem there is that you need to get information about a large number of homes in order to do that modelling. So it is initially a case of you know, scratching the money together in order to put the necessary monitoring equipment into people's homes. I think it's probably, I brought that up, and the fact that we're working in that area is a reflection of just what Gemma was saying, is that the policy is weak at the moment. We don't have a vision. I mean, I wonder whether what there's an opportunity to do is to build a consortium for everybody in the industry who believes this and try and put together some sort of vision of what should be happening, in the hope that something might follow in that way. The idea of doing individual home simulations, trying to come up with something that matches reality, as I say, in order to attract finance. I mean, that would be a sort of holy grail, but that would at least get round the you know, the sort of boom and bust cycle of kind of mini grants, because, you know, that the government putting in their half-hearted attempts to pretend that they're doing something. That would be something that would be scalable.
Yeah.
I mean, the microsimulation approaches that, you know, that you're talking about and that we do do at least provide high quality advice. So if you've got someone who's trying to do something, then it will at least tell them what they ought to be doing, or give them a fair idea of what they ought to be doing. I mean, we work with lots of local authorities and lots of housing associations. Housing associations do have a budget to do this kind of thing, and Gemma was exactly on the ball there when she said that they're looking at the best ways of spending it. Local authorities tend to be just looking for the homes that they can target with the grants that they are able to get hold of. So in a way, it's a kind of a circular process. They are limited in what they're able to do. Apart from, they're a fantastically trusted organisation to be working with. So if the advice from the microsimulation tools can come from the local authority, as we're doing in London and various other places, it adds strength to that. But it's one piece in a big puzzle where lots of things have to fit together.
I'm conscious of time, but also I've noticed that there's quite a few questions in the chat here about the presentation we gave. So I'd just like to address a few of those for the people watching. Urslan asked, how well does the model fit against reality? And this is a good it's a good question, because as you point out yourself, it's a little difficult to assess all aspects of the model given the scarcity of data for benchmarking some of these things. So for example, we have a pretty good agreement between sort of the national statistics for total energy consumption within a local authority and the estimate by adding together the energy consumptions of all our synthetic population. We're usually within about 10% of the actual figure, which is quite good given that we've sort of derived it from a bottom-up model. But assessing the accuracy of some of the other measures is a bit more difficult. And actually, interestingly, quite interesting that David mentioned the idea of sort of putting in monitoring equipment in houses to sort of calibrate the model, because that is basically what you would have to do to check, to have some certainty, for example, that the energy efficiency of the boiler or the thickness of the insulation was what the model expects. The model, for a little bit of interest, and there's another question here from Adam Bricknell about what data goes into this. And this is a good question, because obviously to recreate the population at this scale, you need the data to be available at the relevant scale, and you kind of combine a number of data sets to produce the end results. We have obviously ONS statistics and sort of mostly the census going into this. We also use the energy performance certificates to provide sort of a prior for the energy intensity of the households, as well as the needs of the national energy efficiency data. That data as well provides useful inputs. But some of the building characteristics, they're actually they're modeled basically using a building physics model, so that the standard assessment procedure calculation, and kind of reverse engineering it. So for each household, based on the likely area and number of rooms in it, and what we think its energy intensity is, what are the likely values of, or likely thickness of the insulation, quality of the windows, so on and so forth, that would give you this energy performance. So it's kind of, and obviously that's sort of done through Monte Carlo sampling. So it kind of is testing out several thousand different combinations and finding sort of the optimum solution for that. So it is quite difficult to validate those figures, but it is because we are sort of estimating something that otherwise isn't recorded anywhere. There was another question in here. So Prithvi asked, so it says, commercial sector is responsible for almost 30% of building emissions. Can the model be applied to commercial buildings too? This is actually a good point and a good question. In theory, we've developed it for residential buildings. It's for housing. In theory, some of the data sources that we used to put this together, for example, the EPCs, there are EPCs for commercial, non-domestic buildings, but we haven't looked into that. In theory, it might be possible. In practice, though, the models it's currently built doesn't do commercial buildings. And I think David was having another technical glitch there for a moment. I just saw Adam post a question just now, actually, asking, could we split the data into train, test, and validation sets to be able to assess accuracy? Yes, with calibration data. So for example, with the example of Haringey, we actually had a little bit of data that Parity Projects gave us, which we used to kind of test some of those figures. In those cases, you could use some of the data to sort of train it, if you will, and then you could kind of compare the prediction for the that you would get based off the the footprint and so on to what the model would predict. So that is one option. But even there, that data that we're getting for calibration doesn't include some of those energy characteristics of the building. Sorry, there was one more question here. I wanted to. Oh, yeah. So William Beckwith was asking, what makes AI a good solution to this kind of problem? Why not pursue a more analytical approach? And I guess this is a good question, actually, for our panelists. I think I might bring you in on this a little bit, in that I'd say I'm not sure what we're doing is necessarily, I wouldn't call it AI, I'd call it more data science and modeling. But it's a good question, I guess. From my perspective, the benefit we get from taking this approach is that it allows us relatively quickly to do something at scale with relatively little data. We don't need to collect any specialist data. It's all publicly available data that we can actually access in real time. So it allows us to sort of crunch numbers for a large area rather quickly using public data. But this is a good question, I think, in terms of why take this approach, and why not? Why go for a simulation approach versus sort of just a more analytical, maybe more economic policy approach to sort of addressing this question? I don't know. I guess, Richie, this is very much your work is all about modeling this. But I was wondering if you had an opinion on that.
Yes. So there are sort of national scale models that are purely economic and analytical, but I think the approach that marries the thermodynamics and physics of buildings with the socio-demographic makeup of the households becomes important, especially when we are talking about this tailored approach, where we understand that broadly we understand that there are a finite set of measures that we need to take to make houses more efficient. But which of these measures apply to particular households with respect to affordability, with respect to maximum benefits, with respect to trade-offs, that may be tangible. For all of that, it becomes important to use both the physicality of the house and who's going to be paying for those interventions with respect to energy efficiency. Now, the reason why we cannot take purely a data approach or AI to solve this is because the kind of information you need in order to quantify energy efficiency or the affordability of energy efficiency, that data doesn't exist. So you need a combination of science and some data in the form of EPCs and then you might be able to combine that in the future if there was, sort of a collective, and as David mentioned, a kind of urgency top down and a vision, then you could combine, for example, smart metering data to understand the effectiveness of these measures over time. But we don't have that at the moment. So I don't think AI techniques at the moment can be usefully employed. You need a combination of, the kind of data mining that David is doing, and our team has been doing over a decade in order to understand what's going on.
David, I was wondering if you had a thought on that there. You looked pensive for a moment.
I mean, I agree that there's very little AI in just putting together a housing stock model. It's basically just collating data sets and kind of making reasonable assumptions as you go through.
Exactly.
The EPC data set is much maligned, and to be honest, it is a big muddly mess. We've done our best to reverse engineer it because we worked out kind of how it was deduced, but I mean, that's sort of another story. But if you remember the days before the EPC data set, you'll remember that there was just no data of this kind of thing. You know, we used to stand in the high street doing surveys and giving away light bulbs, I mean, it was just awful. And that data was all proprietary and held by the EST anyway. Finding the proverbial needle in the haystack is something that can be a good approach, where you've got a combination of this sort of data set with other deeper but less comprehensive data sets. The EPC data set is quite unusually comprehensive in that it covers most homes now. I think it's about 40, 45, 50% of homes have got an EPC in the data set. So, I mean, we've done some work with the West Midlands Combined Authority and with GM Greater Manchester, looking at the HHSS, I can never remember the acronym, home health risks of homes. And in those cases, we've got a small number of homes that have been surveyed very extensively for these sorts of risks. We've got a wide variety of kind of open data sets, so census and, you know, where there's radon leaking from the soil and all those sorts of things. And we have this wide microsimulation thing. And we've had some success in sort of combining them in order to try and find out where there are these different risks using AI. I think that's where it comes in, is where we're sort of trying to magic data that we don't have out of the air by combining a wide data set with a deep data set. And that's where we're making progress, and that's where we'd really love to speak to other people who are doing it.
Yeah. And actually, just sort of segueing away from that for a moment, the final question I wanted to pick out of the chat is actually one that sort of links to something you were saying earlier, Gemma, about, I guess, some of the, call them co-benefits, if you will, maybe, but, you know, that when you address energy efficiency problems, you know, the sort of mold and sort of damp in houses, that has health impacts as well. Somebody's asked here about, sorry, I'm just trying to find who it was that actually asked this. Somebody was asking about sort of combining this kind of approach with sort of agent-based transport models and other models that use synthetic populations. And this was, sorry, I can't find your name, but it was a very interesting question about sort of, you know, once you consider, you know, when you take this approach where you have sort of a synthetic population, this kind of microsimulation, could you sort of attach other models and sort of run other models for this population to look at some of those co-benefits? You know, the damp and mold issue and sort of some of the health impacts of that are one thing, but are there sort of other sort of overlapping issues that it might be interesting to explore, actually, if you could run several models with the same synthetic population for a local area?
Well, I'm not a data science expert, so I'm answering this with my sort of policy hat on. But I think the big issue, as David and Rishi said, is the data is lacking and yet decision making is very pressing. So anything that will inform investment decisions is going to be useful. I think your question about linking it to other issues, I think thinking around the health benefits and the health impacts and the socioeconomic impacts is important. But it's also, I think, forward planning to things like making planning decisions. If we're thinking around energy efficiency just of individual buildings, actually the biggest context is about the wider spatial scale. So if the bigger issues around transport, for example, if you're modeling a local authority and you're thinking about your local plan and you think we need, X tens of thousands of new homes in the next, 20 years, this is where we think they're going to go. If you just think around energy efficiency for those individual homes, but you don't take account of their connectivity of those developments, what they add up to in terms of transport, sustainable transport, or lacking in sustainable transport, you sort of blow any of those energy efficiencies out of the water if you can't also model what are those wider connectivity and transport issues. So I think connecting those things up is very important.
No, and I've picked that question out last because I'm going to make a little bit of a plug for the workshop that's starting just after this one finishes, which is actually looking at sort of urban modeling and sort of combining different models to look at that bigger picture, that sort of forward planning and how all the different things link up. And if you are interested, if you are interested in urban simulation, there is the DIME workshop starting at 2 o'clock after this. And while we've looked at using this in the specific case of energy efficiency of homes, of residential energy use, they're looking at using these kind of model, combining different models with a synthetic population to look at some of those bigger picture things. So issues like combining health and energy and transport and energy use and those impacts. So if you're interested in that, please do join them for that. They've got some very exciting panelists as well, and so it should be very interesting. I think our time is nearly up here, but I did want to just sum up on a final note. I think it is clear that we aren't the only ones working on this kind of model. There is other work being done. I think some people in the comments have picked up on that as well. And obviously, Parity Projects has been working on this for a number of years as well, working in this direction. So there is a lot of work being done on this at the moment. I think it is quite good to discuss what the issues that we're actually trying to solve with this are. I think sometimes, especially on the research side, it's very easy to dive in and sort of get busy modeling stuff, but then not always ask, why are we modeling this, or what are we going to do with it? And I think it is good to think about those questions and some of those bigger picture ambitions. I particularly, I think one of my favorite ideas today is that idea of sort of the insurance-backed savings promise, which is a very neat idea. Also, the idea of sort of putting in monitoring, energy monitoring in real houses as a kind of ultimate check of model performance is probably something worth pursuing.
Well, you've got our number. Give us a ring if there's anything you'd like to do.
But yeah. All that I want to finish off with is, I think you have all our contact details. If this is interesting to you, if you want to know more, about our model, if you want to use it, or even if you just want to discuss it, please do get in touch with me or our project team. We'd be really happy to talk about it. We are very much in a phase where we are sort of thinking about how to take this forward and how to make it most useful to the widest audience possible. So we'd really love to hear from you. And with that, I'd like to thank our panelists, Gemma, Ruchi, David. Thank you so much for joining. It's been a really interesting discussion. I think you've all brought a very different perspective, although sort of identifying some common issues despite your different perspectives on this. So thank you so much for joining. And thank you very much to our audience. And hopefully I'll see you around in some of the other events this afternoon.